Welcome to qnawire.
The question's asking about the conditions for inference in the context of a binomial proportion, where the sample size is large and both the number of successes and number of failures are larger than 10. So in this case, and the sample size is 295, and the proportion of children deficient in vitamin D is 20%, that's 0.20. Then in part A, part 1, the number of successes would be 295 times 0.2, which is 59. And the number of failures would be 295 times 0.8, or 1 minus 0.2, which is 236. Construct a 95% confidence interval to 4 decimals. We're going to use the formula, the sample proportion plus or minus the critical z times the square root of the sample proportion times 1 minus the sample proportion over n. So our sample proportion is 0.2. Our critical z at 95% is 1.96. And n is 295. And so to 4 places, the lower boundary is found by subtracting 0.2 minus 1.96 times the square root of 0.2 times 1 minus 0.2, or 0.8, over 295, and that's 0.1544. And the upper boundary is found by adding to 4 places, that's 0.2456. How should this interval be interpreted? Well, the correct interpretation would be we are 95% confident that the true proportion of children who are deficient in vitamin D falls within the range of 15.44 to 24.56%. So that would say we are 95% confident that the true proportion I think what I would go with, I'm going to call it choice B because it's your second one. Explain what the 95% confidence means. This means that if we were to repeat the process of randomly selected 295 children and calculating the confidence interval many times, we would expect about 95% of those intervals to contain the true proportion of deficient children. It does not imply that the particular interval calculated from the sample has a 95% chance of containing the true proportion. So I'm not sure what your drop downs are. But that's kind of what you're looking for. Does the study show that computer games are the cause of rickets? I would pick the first choice in that last one for E. Does it cause? No, confidence intervals don't address causation. You need an experiment with manipulation.